Okay. So you need to know the side lengths and the trig function with it pretty quickly or accurately. Now, I don't have them memorized, so I usually draw all the triangles. Some of you have this stuff memorized, that's fine. But a 45, 45, 90 is actually, it sort of comes from one way that you can come up with it is start with a square that's 1 by 1. So if you start with a square that's 1 by 1, cut it like this, you end up with a triangle here that has a 45-degree angle here, 45-degree angle there, and then you can find the measurements. Now, where did the square root of 2 come from? Right, so and then taking the square root of that. So it's 1 squared plus 1 squared is the hypotenuse squared. So C would be the square root of 2. Okay. Let's look at the sine, the cosine, and the tangent. So the sine would be 1 over the square root of 2, right? Which you can leave because it's a 45, 45. Cosine is exactly the same. And then the tangent's 1 over 1, which is usually written as 1. When you flip these, you get the cosecant here. It's just the square root of 2. The secant.
Why is sine, cosine, sine? Oh, because.
You good? Yeah. And flipping 1 still gives you 1. So those are the values that you sort of need to be familiar with. Okay? Right, so this is called a special triangle in its most basic form. If this triangle was 5 by 5, and then this one would have to be 5 square root of 2, right? Guess what the sine, cosine, tangent, and all those are still worth? Yeah, okay, so it doesn't matter what equilateral triangle you use, as long as it's a 45, 45, 90, you'll have those values for sine, cosine, and tangent.
So it's still going to be the same?
Yes. You don't believe me?
No.
Alright, let's try it with the sine of A. So let's call this side, this angle A. So the sine would be opposite, which is 5, right? Divided by 5 square root of 2. Are you okay with that? Alright, see how these 5's cancel each other out?
Yep.
What do you end up with? Well, 1 over the square root of 2, I believe. Right? Because the 5 here leaves a 1, and so does it here. So you're left with a 1 in the top, and 1 times the square root of 2 is the square root of 2. You believe it now? Okay? Alright, so that comes back to what I said yesterday, that the sines, cosines, and all those values, they don't really depend on the side lengths, they depend on the angle. Alright, a 60, 30, 90, I wrote it slightly awkward. Usually we'd say 30, 60, 90, but it's easier to look at it. If you start with a triangle that's 2 by 2 by 2, where's my marker? There it is. Okay, so if you start with a 2, 2, and 2, and then cut it right in the middle, then you get a 60-degree angle here, right? Still, because it used to be 60, and then this is half of 60, so that's your 30, and there's your 90. So this triangle, if you cut this one in half, and it used to be 2, that gives you a 1 here. This one we're really not sure, so how did we come up with the square root of 3 here? So how did they get that one? That square root of 3 comes from 1 squared plus x squared is 2 squared, right? So x is the square root of 4 minus 1 is 3. So there's the reason that one is the square root of 3. Okay, so if I'm in A, so if that's the 60-degree angle, then the sine of A, so the sine of 60 degrees is going to be what? Square root of 3 over 2. The cosine will be, and the tangent will be square root of 3 over 1, right? Which is square root of 3. Okay, then clearly you can flip them. This triangle can also be rotate it, so I'm going to put this tip now down here so that the 30-degree angle is sort of at the bottom. Wow, that's really not straight at all. I got to do a little better than that. Try it one more time. That's not much better. Alright, so if that's your 30-degree angle, okay, the 1 is now over here, right? This is still the square root of 3, and then this is 2. And then you can come up with the sine of a 30-degree angle, the cosine of a 30-degree angle, and the tangent of a 30-degree angle. Bless you. So at 30 degrees, the sine would be 1 over 2. So now this is your half. That used to be your cosine. They're cofunctions, right? Said that yesterday, I think. If the cosine of 60 is a half, then the sine of 30 must be a half. The cosine of 30 degrees would be what? The square root of 3 over 2. And then the tangent of 30 degrees would be 1 over the square root of 3. And then obviously you can flip those. In terms of memorizing it, most people just memorize the original sine, cosine, and tangent, and then just flip it in case you need one of those. Okay, so those are the two special triangles you're supposed to be familiar with. 3 if you think that the 30, 60, 90 is different from 60, 30, 90. So either way. Okay? We're good? Alright. Mentioned this yesterday then a couple of times. And you can see it well in what we just sort of covered in the 30, 60, 90. And that would be that if A and B are complementary acute angles, so if one's 30 and the other one's 60, then the following relations hold. Then the sine of 30 will be the cosine of 60, and the sine of 60 is the cosine of 30. And then it also holds for the flipped versions, but that's just because you're flipping stuff. Well, what does that mean? It means the following, that if I wanted to write this as a trig function less than 45 degrees, then the sine of 65 is equal to the cosine of minus 65, which is 25. So the cosine of 48, the cosine is the sine of 42. Goes together. 42. The secant belongs as a cofunction with the cosecant, and then that would be 19. And the tangent of 60 belongs to a cotangent of 30. Sometimes in a word problem that might be useful to use that information. Okay? Okay. So let's do a couple of problems. Now you don't have to recognize special triangles. You can just do the math either way, and that's usually what I do, unless I really can obviously, like if I immediately see it, I might use it sometimes. But if I'm asked to find the sine, cosine, and tangent for angle A, and they tell me that A equals B, so they're both 2, and C is the 90-degree angle, then I'd still probably draw this little triangle. Okay, and at this point I might realize that this is what kind of a triangle? Okay, they're all going to be right triangles, right? Ashlyn? Said all triangles are right in this problem? Okay, well, so then you have, we'll call this A. Then you have a couple of choices. You either have this memorized, and these two are equal, and the tangent of that is 1, without really doing any work. Or you can just do the work and say, well, the sine of A would be opposite, which is 2, divided by, and you just got to figure out what this thing is worth. How do you find out what that is worth? Alright, so obviously this takes more work, so that would be x would be the square root of 8, which you would be expected to break that down. So then you get 2 divided by this 2 times the square root of 2. And then you reduce those, which you would be expected to do, and you still end up with 1 over the square root of 2. So you can see that it would be beneficial if you can recognize them and you have some of that memorized. Does that make sense? So there's number 1.
I'm confused still.
Where?
What are you trying to do here?
Huh?
What are you trying to do here?
Find the sine, the cosine, and the tangent.
How is it going to be close? Oh, they're the same thing.
On my first method, I have it memorized that at 45, 45, 90, the sine and the cosine are both 1 over the square root of 2 and the tangent is 1. So that's how I got my answers quickly. And then I did try to show you that even if you don't have it memorized, you can always draw the triangle, find the hypotenuse, and then just do the math with it that way. So it will work either way. So until you get familiar with these, don't, like if you're not really sure, just draw triangles. So if A is here, then the square root of 3 would be here. Well, the square root of 3 is a little bit more than 1. So then I'm going to put B over here. And then, if you don't recognize what kind of triangle this is yet, that's fine. You can still do the math. Right? Hypotenuse is not given again. So that means x squared is 1 squared plus the square root of 3 squared. So x would be 1 plus 3 is 4, and the square root of that is 2. And then you write down what your sine of A is, your cosine of A, and your tangent of A. In this case, square root of 3 over 2, 1/2, square root of 3 over 1. And honestly, this one, I don't have it memorized, because the 30, 60 are the same triangle to me, so I sort of have to do the work. How about number 3? If A equals B equals 5, what do you have? S is a 45, 45, 90. So without drawing the triangle, I can tell you that the sine is the same thing as the cosine, which is the same thing as we did in number 1. And the tangent here is going to be 1. You could draw a triangle and do the math. And we end up with the triangle that I showed when Ursula didn't quite believe that the sine and the cosine and the tangent would be the same even if it was a 5 by 5 by 5 square root of 2 triangle. Okay? How did I get this? This one I have in memory because it's a 45, 45, 90 degree triangle. The sine, the cosine are always 1 over the square root of 2 and the tangent's always 1. Again, if you struggle with that a little bit initially, which is fine because we just started this, but if this is 5, this is 5, this is 5 square root of 2. The sine would be 5, so the long way here would be to say that the sine of A would be 5 divided by the 5 square root of 2. What happens with these 5s? They would cancel, and you're back to the answer that I started with. Can I erase the ink? So I'm out of room and I need to do 4. So 4, they switched it a little bit. They didn't give us A and B, they gave us C, right? Yes, no? Yeah. Alright. We're good? Yeah. So, since they gave us C, I'm going to draw it. So if this is 10, and A is 5, I didn't draw that very well, did I? It helps to have somewhat accurate pictures. 10's way more than 5, isn't it? It's twice as much. This is 10, we'll call that 5. So that's 10, and this is 5. Then what is this side? Well, if you're not sure, it would be x squared plus 5 squared is 10 squared. So x squared is 100 minus 25, which is 75, right? So it's the square root of 75, but that's reducible. That's 5 square root of 3, because there's a 25 in there. That's the square root of 25 times 3. Okay, this is a special triangle, guys. You'll see it here in a second. So, again, I do it from that perspective, with this being a. So so the sine of a would be what?
This is a 16, 30,
Yeah.
90, right?
It's 5 over 10, which is a half. This is actually a 30, 60, 90. But I don't have these memorized either, so cosine would be 5 square root of 3 divided by 10. Well, that reduces to the square root of 3 over 2. And the tangent here would be opposite over adjacent, so 5 divided by 5 square root of 3, which is just 1 over the square root of 3. So if you don't quite see it, and this one's a little trickier to see, that's fine. Just take a little longer and you can get the answers. It's not different from what you learned in the first part of 1.2. Okay. A little bit more abstract now. We do have a picture here for 5. What do you know about the sine of the 45-degree triangle? It is 1 over the square root of 2. Well, how in the world does that work if that's unknown and that's unknown? If you don't quite believe that that's true, it would be opposite divided by hypotenuse, right? And a divided by a is 1 square root of 2. So you see how it comes out again? Same way? Yes? Okay, so we know that the cosine is the same and the tangent is 1. And the same thing works over here in 6. It's a 30, 60, 90. Well, I just did that, didn't I? So the sine of a better still be a half. If you don't quite see that, just use your definition and say it's opposite, which is a divided by hypotenuse, which is 2a. But you've got to simplify, and a divided by a is 1, and so you end up still with a half. So that means that the cosine here will be the square root of 3 over 2, and the tangent here is 1 over the square root of 3. So these can be made to look a little bit funky and weird. Don't, as long as you sort of know what you're looking for, it will work out. Okay?